Hello and welcome back. We're going to talk about methods in this segment, and in particular, we're going to talk about static methods in Java. And it's a little bit tricky to talk about this because you don't really know what static means yet. You're not supposed to fully understand that, but you can have this discussion about writing methods in Java, and we can do some practice exercises with those. So let's talk about methods in general, what they are. In other languages, when you divide up your code into modules, you might call them functions or subfunctions or subroutines. None of those words are used in Java. We're going to call them all methods. And the method that we've been using all along is called the main method. And that's the entry point, or where the program starts executing for all Java applications. And we can add more methods, as many as we like, even within the scope of a single class. And that's where we'll start. We'll define functional modules called methods within the same class, and we'll call those methods from the main method. So I'd already talked about this. There are static methods and methods that belong to objects. And I hesitate to say it, but those are dynamic methods. There is no dynamic keyword in Java, but there is a static keyword. And we haven't looked at classes and objects yet, so there's nothing to compare static methods to. That's okay. We're going to take it one step at a time, and we're going to learn about calling methods that we define in Java, static methods in particular. Okay, so let's look at the anatomy of a method. So here is a class which I creatively called hello, and this class goes from here to here. So this whole slide is one class, and what you're used to seeing is the public static void main, which is the main method, and now we're going to add another method inside of the same scope. So notice how it starts to be important that the indentation is always correct, and the close brace appears on a line by itself. So when you just kind of blur your eyes or stand back from this, you can see that, okay, there's something that starts there and ends there, and there's something that starts there and ends there. So don't break that rule, and make sure that you ask Eclipse from time to time to reformat your code for you so that you'll always have things lined up the way others need to see it. So here's the method that we're going to define, and I'm going to call it cube. We're going to cube something, which means multiply it by itself 3 times. So here are the component parts. We're going to start out our methods by saying that they are public static without knowing what that means. So here's the real part of the method signature that we're going to learn about. The return type, the data type that this method returns, must come just before the name of the method. So the name of this method is cube, and this is the parameter list. So this is how the method receives data from the caller. So when you call this method, you're going to pass something into this parameter. So you don't have to do this, but I think it really does make things a little easier. Whenever I'm defining a method that returns something, I declare a variable called result of that data type, and then the last line of the method is to return that result. So then it's a fill-in-the-gap problem. Calculate what the result is that you're going to return. So here's the call to the method. We mention the method's name and pass something into it that matches the parameter list. So this is called the arguments. There's only one right now. The argument 7, which has data type of int, is going to go into this local variable called parameter. And then we're going to multiply parameter by parameter by parameter, which is 49 times 7, whatever that is, I don't even know. And then we're going to return that result. So the return value is what this method call evaluates to. So whatever the cube of 7 is, this method call will evaluate to that number and be assigned to this variable. So that's how it works. It kind of should look familiar to you. In the old days of writing functions in mathematics, we would write y equals f of x. And that's where this syntax originated from. But it's not an equality relationship anymore. It is do this function on this data, and whatever you get back gets assigned to the left-hand side. Okay, so I think what we'll do is just go into Eclipse and start typing some simple functions until we get the hang of this. So I'm going to just start off by defining a method that we looked at in the slide. So a public static, and we don't know why, returns an int, and we're going to call it cube, and it takes an int parameter. There should be in your applications a reasonable name for that. We don't really have a reason for cubing something, so that parameter doesn't have a very descriptive name. So I'm going to declare the result variable, and I'm going to return the result. And then in the middle, I will calculate what the result is. And the result in this case is parameter times parameter times parameter. Okay, that's really all there is to it. This is a functioning method now, and I hear myself once in a while accidentally saying function. So if I do that, translate it for me into method. Methods can be in any order. This method could have come above the main method, and the compiler doesn't care the order of the methods, but it's really typical that you would expect to see the main method at the top, because that's where you would start understanding what the program is doing. So what did I call that in the slide? Cube of 7. And now I'm going to write cube of 7 gets, and I'll call my method and pass a 7 into it. So the name of your method must include a verb. So cube in this case is not like a square shape. It's the verb cube this number. You might be more familiar with square this number, but there's already a method for that, so I decided not to write one. So a verb that describes what the method does, and the method should really only do one thing. That's a good design in Java, and your methods should be fairly short. Rule of thumb is if you've written more than one page in a method, or one screen full, your method is probably as long as it should be, and you should start dividing it into sub-methods. Since I admitted that I don't know what the cube of 7 is, I'm not going to multiply it, I'm just going to run it and see what it does. So the cube of 7 is 343. And I'm going to set a breakpoint here so that, no, not there, I'm going to set a breakpoint here so that we understand the flow of control. So when I run this in the debugger, it will change the perspective. And now we have the arrow points at the line which is next to execute. And since we're pointing at a method that we wrote, we might want to step into that method and watch its flow of control. So we have a button up here which we haven't used before called Step Into, and I'm going to step into that method, and you should see that this variable parameter has the value 7 in it, the value that was passed in from the caller, or from the main method in this case. And when we now execute one line of code at a time, the result value is 343, and that's the value that will get returned in this statement to the caller. So return result, if we execute the return, we're back on this line of code, and the assignment has not yet happened, but this expression, cube 7, has finished, and it has evaluated to 343, and now we're going to assign it to the variable cube of 7. So that's the flow of control with methods. When you call the method, you step into the method with the data that was passed in, and you execute the code in the method, and then you come back with the value, if any, that the method returns. Okay, so I'm just going to kill that one there, go back to the Java perspective. A method doesn't need to have a return type. Well, that's not true. A method must have a return type, but sometimes the return type can be void. So this is the only place in the entire language that the keyword void is used. So here's a very, very simple message that doesn't have any return statement in it at all. And you notice that it compiles already. And that's because we don't need to return something all the time. If our job is to just output some messages, then we don't need a return statement. So now, if we call that method output messages, we call it without passing anything because the parameter list is empty. You have to spell it the same way. The parameter list is empty, and the argument list is empty, and the method doesn't return anything. So let's run that and just make sure that it's doing what we want. It prints out hello from a method. So you can take some code out of the main and put it into a method to make the main easier to read, shorter, less complex, and you can reuse these methods. So if I have lots of times that I need to cube a variable, I wouldn't need to write the code to cube it over and over. I could just call the method that I've defined previously. So I passed a constant into that method, but you don't have to. You can pass a variable in. So this does the same thing because this variable has a 7 in it. But it should be fairly obvious to you that you can pass in anything that, in this case, is an int, and maybe not so obvious that you can also pass in anything that is promotable to an int. So you know all of the primitive data types: byte, short, int, long, float, double, in that order. So what is promotable to an int? A byte, a short, an int. Okay, so a byte, short, or int can be passed in there. Also, a character. So this would seem very strange to mix characters with ints, but remember that a character is just a code, an integer code that represents that particular character. If a method returns void, it wouldn't make sense to have the result of the method call be assigned to something, and this doesn't compile because the compiler already knows that this method returns void, which can't be assigned to an int. So a method call that doesn't have something before it, like the cube method did, is probably going to return a void. This one, the only reason for calling this method is that it would return the value, which is the cube of. So throwing that away, you could do it if you wanted to, but throwing away what that method returns doesn't gain you anything. The method call is of no value. Okay, so your parameter list, you can have as many parameters as you want, but if you've got more than 3 or 4, then maybe your method is too complex and you're trying to do too many things. There's an old joke that the question was, how many is too many parameters? And the answer is, if you've got more than 5, you probably don't have enough. Because when the complexity starts building, then the complexity tends to breed more complexity. So keep your methods simple, doing only one thing. Okay, there's only a couple more things to demonstrate in here. Suppose I have an array of ints, and I'm going to initialize that array to have some numbers. And now if I want to pass an array into a method, suppose I want a method that would find the average of the numbers in that array. That might sound familiar to you. I'm going to ask this method called findAverage to take an array of ints and return the average of that array, the average of the elements in that array. And this doesn't compile yet because we haven't defined the method. So let's make it a public static double, and it's called findAverage, and it takes an int array. I probably shouldn't call it A, or all of your variables from now on will be single letters, and you'll say, well, it's because he did it. I hope you're smiling. Okay, so there's my standard way of doing it. Declare a variable called result, and then at the end return the result, and then in the middle calculate the result. So let's make a sum variable and put 0 in it, and now a for loop. I is less than what? How many elements are in the array A? If you said 4, that's wrong. The answer is A's length. So we can pass in an array of any length, and the array knows how long it is. So we'll ask Java to loop over the array. Oops. Trouble typing. Okay, so how do you find the average of an array? I'm putting it in result, and I'm going to say the sum divided by array's length, and that will work, but there's a bug. The bug is that this is an integer division, and we wanted the result to be a double. So let's use an upcast here, and we'll cast sum to be a double, and then do the division in double. The formatting for vertical space in Java is that you leave a blank line before a control structure, like an if statement or a loop. You don't leave a blank line after it. So you can leave a blank line after your declarations, before a control structure, between methods. Here's something that you cannot do. putting your braces at the end of a line like this makes it impossible to read. It compiles, but that's not correct formatting in Java. Eclipse will format your code for you. So right-click in the code window and look for the source menu and then say Format. And the default for Eclipse is that it will put things in the right place. And it matches the Java standard for formatting. It's free. It takes about 1 second. Format your code often. It will help you to find the bugs that the compiler doesn't. So let's just output the average. And make sure that we've done it correctly. So the average of these 4 numbers is 31.25, and that seems to be working. Okay, so I encourage you to type in the code that I've typed here in this exercise so that you get familiar with passing parameters into methods and defining methods of your own. There's the return type. There's the name of the method that returns a verb. This one is find. Maybe calculate would have been a better verb there. And here is the parameter list. The methods return something if their return type is not void. I'm slowly scrolling through this in case you needed to review something that was on there. Always set breakpoints. When your code is doing something and you don't understand what it's doing, you're wasting your time unless you set a breakpoint right away and ask the machine to show you what it's doing. A brief summary of the things that we've looked at in this segment. Java methods, not functions, even if I say that by mistake from time to time. Java methods must have a return type, even though that may be void. The name of a method in Java is always with camel case. That means it starts with a lowercase letter. The name of a class always is title case. That means it starts with an uppercase letter. The name of a method should always contain a verb. A method does something. So ask yourself, what is this method doing? And whatever you say should be the name of the method, even if that's 3 or 4 words written in camel case. A Java method always has a parameter list. That means there's a set of parentheses there, even if the parameter list is empty. That's still an empty list. For now, our methods are always going to be public static. Those methods should do one thing, and that one thing should match their name. And methods can be used to break complex problems into easier problems. And they shouldn't be too long. You should be able to pretty much look at a method, look at its name, and see what it does. And that really makes reading the code easier. I wish I had put on this slide that we need to have correctly formatted code, so the indentation and the position of the braces starts to get more and more important. It's kind of like reading English if there was no space between the words. That would really slow you down and it would be annoying. So we're going to write Java code that is easier for someone else to read. Very good. Let's end this one here then, and we'll look for some exercises that you can do with static methods.